और हाँ, रिग्रेशन भी तो करना है यार, रिग्रेशन भी कर लेंगे आज ही।
चलेगा, जो एग्ज़ाम में आता होगा ना वो बता दो।
पीपीटी से रेफरेंस ले लिया सर?
हाँ हाँ, पीपीटी से देख लिया। उसमें बस अभी एक चीज़ जो है, कहाँ चला गया यार, सामने ही है, बायस वेरिएंस ट्रेड ऑफ जो है ना, ये अपन कल करेंगे। लाइक ये वाला यूनिट कल कंप्लीट हो जाएगा, नेक्स्ट यूनिट भी चालू हो जाएगा साथ में।
मतलब आपको समझ आ गया ना सर ने क्या कवर कराया
हाँ
था?
हाँ हाँ।
यही है। बढ़िया सर, बढ़िया, ठीक
हम्म,
है, ठीक है।
हम्म।
और अगर हो सके तो सर असाइनमेंट्स भी समझा देना, उन्होंने अब तक 1 या 2 असाइनमेंट दिए हैं,
ओके ओके।
तो वो भी समझा देना आपको जब भी ठीक लगे। हम
हाँ।
लाइक वैसे ही क्वेश्चन एक्सपेक्ट कर सकते हैं इनसे,
हम्म।
तो वो भी एक बार देख लेना।
ठीक ठीक ठीक। तो वो अपन है ना कल एक बार डिस्कस कर लेंगे, जो पहला असाइनमेंट वगैरह था ना जो उसका, वो है ना? चलो अब स्टार्ट कर दें क्या? नहीं, प्रसन्न, प्रसन्न रिकॉर्ड कर रहे हो?
हाँ हाँ चलो भाई, कर रहा, मैं अभी कर रहा।
ओके ओके। चलो फिर है ना, फर्स्ट ऑफ ऑल एक सेकंड स्क्रीन शेयर कर लूँ। Sharing the screen, entire screen, screen 1 share, there we go। और साथ ही साथ नया पेज कहाँ से जोड़ते हैं इससे, यस। तो आज अपन बात करेंगे हाइपोथेसिस, वीसी डायमेंशंस, और एक्चुअली में बिकॉज ऑफ दीज टू थिंग्स अपन बात करेंगे कि जो मशीन लर्निंग प्रॉब्लम्स होती है ना, मशीन विल आल्सो टॉक अबाउट मशीन लर्निंग प्रॉब्लम्स, ठीक है। So first of all, let's discuss ki what we are trying to solve with machine learning, right? That is how we understand like what we exactly call hypothesis, and then why we need VC dimension as well. So, for example, you might have a problem which, let's say there's a, I'll just like write it like this question. So this is our problem that we want to solve. The problem we want to solve. Right? And there are a certain few paths that we can take to solve this problem. So it might be like you might ask one question, which might be true and false type of question. And then you might ask one more question, either way, like whichever way you go, which is also true or false kind of question, right? So this problem has like 4 outcomes here in this case, like with just 2 levels, there are 4 outcomes. This is the first one, this is the second one, this is the third one, this is the fourth one, right? And what we are talking about when we talk about machine learning problems is how we kind of like mathematically represent this path of solutions, and how we can like let's just write it down, how it is represented mathematically, all right, and also how many solutions there are. So how many solutions there are. So just representing these two things mathematically is what machine learning, that's the first step to solving a machine learning problem. And what a hypothesis is basically you being able to tell apart all of these scenarios from each other using a mathematical function. So this being part of the set of hypotheses, so this might be a set of hypotheses. This would be like, let's make it H1, let's make this H2, let's make this H3, let's make it H4. So this problem can be solved with just these sets. So H1, H2, H3, H4. But you have to like find one of these as a solution. There can't be more than one solution, right? So this is what exactly we are talking about when we are talking about hypothesis in machine learning. And the best way to understand this is using a graph that we use in the VC dimension as well. So imagine there are like 4 scenarios, 1, 2, 3, and 4. These are all four decisions, these decisions that you can make. So you can reach this decision, or you can reach this decision, or you can reach this decision, or this one. You can reach only one of these, right? So basically what's happening here is you're trying to find a function which, so function could be like, it could be a curve, it could be a line, you could have a circle, that's or you could have like a rectangle as well if you want. Actually it doesn't matter as much, like you could, as long as you can write it down mathematically, you can have that as a function. And what you're trying to do is you're trying to figure out a way where you can pinpoint each one of these individually. So imagine if I were to say that this is the solution for my answer, for my problem. This circle is the solution of my problem, which means everything that lies in here will be a solution to my problem, right? And if I were to say at the same time that in another scenario, this is the solution, in this case, this becomes invalid for us because there are like, we want to, like I said earlier, we want to reach only one scenario, either H1, H2, H3, or H4. Over here, we have like two of these scenarios selected, this one and this one. So this becomes invalid for us. So that is one thing that you guys need to understand, that when we are trying to solve something using these mathematical functions, what we are trying to do is we're trying to separate out one single part of this, uh, you know, um, one single solution. We're trying to separate it out using this line or using this shape. So basically, in this graph, you can see that this one is like separated out from these three. So that is very much possible. On the other hand, if I were to do something like this, then this becomes separated from the other ones. If I make it something like this, then this becomes separated from the other ones, and then there is also this, right? So this is also very much related to the VC dimension problem, which is and the shattering part. So you guys have to like kind of think of this whole hypothesis and VC dimension and machine learning problems all as a one single concept rather than like different things. So let me also give you an example. So by the way, so far any doubts in like what I have like just told you guys about, like any doubts that you have to reach one solution in here like to each problem, or any doubts in like this hypothesis set and these possible solutions? Any doubts here or in this diagram over here? Okay, so since nobody is saying anything, I'm guessing there are no doubts. So now we can move on to one example. Let's write it down. Okay. So I want you to think about this as a computer science engineer, or when you want to write an algorithm for this specific problem. That is the best way to understand this problem. So the example problem would be like writing an XOR gate, say, writing an XOR gate in Python. Like you can just write it in Python. Now the thing is, what are the possible inputs and outputs for an XOR gate? There is like zero. I'll just write. I'll make the truth table. So 0 0 0 1 1 0 and 1 1. And this example might, if it confuses you, then don't worry. But it is for those people who like kind of understand the decision making part of this. So this would make them like a lot more comfortable with the concept. So if I were to run an XOR between these, uh, this would become 0, this would become 0, this would become 1, and this would become 1. Now, when we have a decision tree, so when we talk about decision trees, there are two inputs we can have and one output. So let's talk about how we write this problem down in a decision tree. So the first question that you're going to have is input 1 on or off. So input 1 is on or off. If it is on, that is true. Then you ask if input 2, this is the same question you're going to ask on the both sides, by the way. So input 2 on question mark or off question mark. True, false, true, false. If it goes down this path, it is supposed to be 1. This is supposed to be 0. this is supposed to be 1, and this is supposed to be 0. So this is a decision tree for XOR gate. Like this question is being asked over here and over here as well, by the way. So that's like either way, like whichever branch it goes to. Now the thing is, imagine if these decisions, like you come down this path and ask a question, and once you answer that question, you know it's either going to go this way or this way. So you can have one single variable, say I'm going to write it as W for now, one single variable which kind of shows us that if the first input is like on or off, what it is supposed to do. This variable shows that, and I'll just write this as W1. And then when it comes down to this part or this part, there is another variable for the second. So this variable 1 is like associated with the first input, and the variable 2 is associated with the second input. And this one can also have an on or off system. So let's write it on or off. Now the thing is, if you were to store certain numbers inside these variables, you will realize eventually that it will be between somewhere, say it's on a it's going to be on a scale, but it will be somewhere between say 0 and 1 if you normalize it properly. And this between 0 and 1 purely depends on like what the input is going to be and how that input is being treated, by multiplying this variable into that. So imagine this input is, let's say input 1 is going to be 1 and input 2 is going to be 0. In that case, if you have weight 1, which kind of pushes you towards a left decision making, and then weight 2 is something that pushes you towards the right decision making for this specific 0, what it will do is it will first take this one. So if it is true, it will go into this direction, and that decision is like primarily stored in the weight, like this W1. Um, this association over there, W2 being associated over into this question. And I feel like I can like remove certain parts of this 1 second to make it a little bit more legible. Okay. So this weight and this weight, or W1 and W2, is going to eventually learn, like they will be adjusted in a way such that it is always going to make certain decisions rather than making certain other decisions based on the input. So if this is the input, it is not going to make this decision, but it is going to go left and then it is going to turn right. So this decision for this specific input. And on the other hand, where you have, let's say, 0 and 1, so just the opposite of this, it will take towards the right first, it will go down, and then it will take towards the left again. So this is like two valid decisions to be made. If it is 0 and 0, then it is just going to be like going there and then left again. If it is 1 and 1, then it is going to be the right and then right again. So these four patterns are going to be like some combination of these weights or these variables when we are like trying to learn. And this is going to be like a combination between these two variables, like as well. They will be like they will be dependent on each other in a way, like if this one W1 is like closer to 0, then W2 is going to be higher. So something like that for a problem like this. This is a linear problem in that case. So yeah, these four decisions. So these are the four decisions that can be stored just by adjusting these two variables when we are programming, basically. And that is basically how we are like, how we usually design an XOR gate when it comes to machine learning. Although we don't do it with machine learning, they're not the best. XOR gate isn't the best problem to solve using machine learning. It can be just done with a normal algorithm. But yeah, you can store these, all four of these, in certain combinations of W1 and W2. Now the thing is, W1 and W2 are both binary in this case, like they go between 0 and 1, which is why there are multiple states of W1 and W2, of which all the combinations gives out four different scenarios. So like these are the four scenarios already made here. So these are the four scenarios. Scenario 1, 2, 3, and 4. So because these are like binary, you can do it with just two of these. And so this is also how we represent. So these four things can also be represented using the same graph like earlier, like the one that we made up there, this one, because there are four outputs, like four possible outputs to these four possible combinations of inputs as well at the same time. So yeah, you can represent it either with just these weights, or you can represent it with these decision tree paths, or you can represent it using this one. And this is the standard form for representing, like how we represent it. And this is a linear, like this is called a linear problem. Let's write it down. And the reason it is called a linear problem is because this one can be solved using just a line and nothing else. And so that or that decision can be made using just a line. You do not need anything else. So that is what you're trying to do with like this specific, like that's what we're trying to do with this specific example, is to understand that these all of these things can be represented, like these can be encoded with like weights, these can be encoded with decision trees, and these can be encoded with this kind of diagram as well. And that's pretty much like what we use for the VC dimension as well. And I'm like kind of apologetic about like this part where like it might not have made sense for everybody, but if you've done like a lot of algorithms where you have to make a lot of decisions, then this might make a little bit of sense. And you can like store them in variables, these decisions. That's kind of important to understand. Okay, so now let's also talk about the like, because of this example, and we coming down to this specific diagram, let's move on to what exactly are we trying to do with VC dimensions. So let's talk about VC dimensions.
तो अभी तक जो कवर हुआ है वो हाइपोथेसिस इवोल्यूशन कवर हुआ है।
Bhavesh, can you repeat that?
अभी तक जो कवर हुआ है वो हाइपोथेसिस इवोल्यूशन कवर हुआ है।
हाँ, that is like it's just a basic definition कि ये hypothesis वगैरह क्या है. I mean, it's not the same hypothesis as you remember last semester, na? And all we're trying to do, yeah, hypothesis here just means it's a set of all possible answers, and the ones that can be classified. So let's talk about classification now. VC dimension का हिस्सा. So let's talk about what a classifier is. Okay, let's scroll up actually. I'll quickly write something. Okay, these over here. So these things are called classifiers for us. Classifiers. And what this does, it just classifies these things into different, parts. It's basically like, you want this specific answer. Can this line classify it? Yes, it can classify it. Very much possible. So yeah, it is like, these are what classifiers are like. When you're trying to make these, all of the possible outcomes, you make actually, let's make a different one now. Let's make this one. Okay, there we go. So with 5 decisions, imagine if there were like 5 decisions to be like, 5 possible outcomes, and I'll write these like H1, H2, H3, H4, and H5, and so on. That would make this hypothesis being equal to a set of H1, H2, H3, H4, and H5. And this hypothesis is what we kind of, this is not the same testing that we do like that we did in the first trimester. But what we want to do is over here, we want to find a function. So function, let's quickly talk about what those are as well. Functions are basically something for which X just yields Y and nothing else, like one-to-one relation kind of thing. So those are functions, right? And basically functions, if you plot it on a graph like this, you end up with a curve, you end up with a line, you end up with a circle or something like that. So what you want to do is you want to find a function which can classify all of these individually. So for example, can a line like classify this somehow? Is it possible to classify all the points? So let's look at that. Like, yeah, this point got classified, that's good. This point got classified, that's good. This point got classified, that's good. And this point got classified by this line. So, if it was this line, that upper one got classified, no issue. But how do I classify this point in the middle with a single line? Does it look possible? And like, and can you think of, can anybody think of a way where we can like separate this middle point from the other points just by making a line like this? Can you guys think about any of such ways, like any such way? Doesn't make sense, right? You can't really do that. Like if you were to make a line over here, it separates 2 versus 3 points rather than just this 1 point. If you were to like create it like over here, then it's 4 and 1, 3 and 2 again, that kind of thing. So over here what is happening is this thing, not exactly like being able to classify one specific. So if this was h1, this is h2, this was h3, h4 and h5. In this case we cannot classify h3 using a linear function. So we cannot classify h3 using a linear function. So does that make sense to you guys? Like we cannot classify it using a line. And if we were to create a circle, by the way, then does anybody know how to offset a circle from the center, like origin? Most likely not. And if you can offset a circle, like basically if you were to create a circle to classify these things, this function would become very complex. Creating a circle at the origin is very easy. You just do x square upon something, like I forgot what it is, but you do something like x square upon something and it just becomes a circle at the origin. But if you were to like do an offset, then you would also have to like add two more offsets to this, say w1 plus w2 or something like that, to actually move the circle around on the graph, which would make this more complex function, which is exactly what we call overfitting, by the way. So the more complex a function is, the more, let's write this down, the important part, the more complex the classifier function becomes, classifier function becomes, more overfit it is. So more overfit it is. So you cannot make a function which is like very much like it wants to just point out that this is the result, or this is the result, or this is the result. In that case, what will happen is when your data set changes from this specific set, this function will stop working altogether. So you want functions which can be like used for multiple scenarios as well. So does that make sense to you guys so far, like classifiers? Any doubts on classifiers? Because literally like this part is called, okay, good. So let's quickly talk about shattering, and then I'll just define instantly what a VC dimension is. So shattering. So think of your hypothesis. So a hypothesis being made out of like say 5 results. So hypothesis with set of 5 results. So in that case, we write it as H1, H2, H3, H4, and H5. Makes sense so far? All good? Now, this hypothesis will have how many states that you want to classify. With 5, it is kind of simple. It is just 2 to the power n. That is how many states there will be. And I'll quickly show how that happens. So if there were two, say just H1 and H2, if there were two of these, that would be 2 to the power 2. And how do you classify them? It would be like none. So this is no classification. So this is none. Say this is H1, the bottom one gets classified. So H1. So H1, yeah. Then you would have the upper one being classified. So that is H2. And then all of them being classified as, just all. So these are the 4 scenarios, 2 to the power 2. That's it. So now we have one thing that is different from what we just studied, and that is this case. And let's quickly talk about that as well. So if we come up here and we look at all the scenarios H1, H2, H3, H4, and H5, there are certain problems, like most of the problems, like there are certain problems that actually don't do this. So those are like very few compared to like how many requires you to like classify multiple things together. So most of the times when you're using a classifier, you will have multiple data points that will actually be your result. This one specifically, the example of decision tree, this one, on this specific one, this hypothesis does not, this kind of hypothesis and shattering does not work, because this is like very linear, like this is an extremely linear problem which can be solved without even like machine learning. So the actual problems, when we start solving them, we usually have like sometimes where you want to classify all of the objects together or none of the objects together. And at the same time, if you look at this scenario of 5-1, this one, the 5 hypothesis part, you want to classify 2 of these, 3 of these, but the problem here was that we couldn't classify H3 alone. So we want to classify everything alone, everything in some combination, and all kind of sets. So if you have a set basically, so this set, whatever subsets you can make out of it. So I think it is called a power set, right? Power set. You want to be able to classify all of the part of the all parts of the power set. That's what you want to do. And if you can classify all of them, it means that you shatter that problem. So that's like if you can classify these four using a line, so just a line, y is equals to mx plus c, just using this line you can shatter this. I mean, you can classify all combinations of this. It means that you have shattered this problem. So this has been shattered. Does that make sense? That is what shattering is. As long as you can classify it, that's going to be like you're done with that. And on the other hand, this one we couldn't shatter using a line. It wasn't possible to shatter it using a line. So that is what shattering is. So do you guys understand like what shattering is? If you understand what shattering is, then we will quickly define VC dimension now. Okay. So VC dimension is the highest number of collection of hypotheses. So highest number that can be classified or shattered, classified or shattered using a function. And that is literally what VC dimension is like. There is no other definition to this. All you want to do is so if we had like 2 of these, so 2 to the power 2, let's make like 3 and 4 as well actually. That way you guys can understand it a little bit better as well. So imagine if there were h1, h2 and h3. This is our like overall hypothesis thing. So that is going to be 2 to the power 3, which is going to be 2 into 2 into 2, which is 8, right? I hope it is 8. So if there were 3 of these, we can classify none of them. If there's 3 of them, we can classify one of them. If there's 3 of them, we can classify 2 of them. If there is 3 of them, we can classify other 2 of them. We can classify the last 2 of them as well. So like this, and then we can classify. Have we classified each one individually? No, we haven't. So I'm gonna like write. I mean, so this one got classified. There we go. I'll just like make it like that, so you know what got classified. These got classified in this. These two. By the way, when you create these lines, you can always make an arrow to show that what it is classifying. So this one is classifying nothing. And if this was a longer line, this one is classifying in this direction. This one is classifying in this direction. This one is classifying in, sorry, that is in the other direction. This one's classifying in that direction. And which one is this? This is a single classification. No, this is a double classification. So it's in this direction. This got classified. This got classified, and then 3 more. I'm like making these too close. So these 3. Now this got classified. This needs to be classified, and this needs to be classified at top. So those are 7 of them, and finally we need to classify all 3 of them as well. So all 3 of them gets classified, and these are all 8 of these. Make sense? Any doubts here?
No, good to go.
Okay. Think you guys can do the four one, like the four. What do you call it? Four element thing, like four hypothesis part thing with a line. Okay, good. Then go ahead and try that. And that is pretty much what VC dimension is. And what does it help you do? It kind of, okay, so let's now talk about like what exactly it does before we, move on to the four thing problem. Okay, so now our problem is we have a question. So we have a question and it has say four solutions now. And you have a function which is say beta 0 is equals to, no, actually, you write it down like, capital Y is equals to beta 0 plus beta 1 x1 plus beta 2 x2. So actually, you know what, this has to be like a linear. Okay, this is linear enough. This one is like, this is a linear enough equation. All we have, all the VC dimension tells you is if it shatters. So if it shatters, then this problem is solved by this equation. It basically just means that it is solved using the equation that you are using. And what is that equation? That is equation is the line that you are using. Like this equation is actually a line that you are using to classify your objects. This equation could be like a proper curve, like higher dimension, higher order equations, and you can definitely use curves to classify things. Nobody is stopping you from doing that. It's just that you don't want it to be too complicated, otherwise it is overfit for your specific problem. So yeah, that is what it is useful for. So the shattering and the VC dimension, that is what it is useful for, to tell if a specific equation or a specific function can actually classify the the problem or not, the solutions or not. And that is what those solutions are called, the hypothesis basically. So everything so far makes sense to everybody? Any doubts? Any doubts? Because then we can start with linear regression. I'll quickly export this page to PDF.
अभी जो आपने सर क्वेश्चन करवाया ना वो बताया और दोबारा समझाना, मेरे को समझ नहीं आया।
ओके, ये वाला,
हाँ, एक नहीं, ये तो आ गया उससे अगला। हाँ,
ये
ये।
लास्ट वाला।
हाँ हाँ।
नहीं, एक्चुअली मैं क्वेश्चन नहीं कराया है. ऑल आई एम सेइंग इज, I mean, this is like not a question. All I'm saying that this is a problem. So let's go to draw, remove this, and I'll write a problem here. So problem which has four solutions, right? And
ठीक
we
है।
are trying to solve it using this classifier. This is our classifier that we are trying to use to solve
हाँ
it.
हाँ
So
हाँ।
four solutions might be like arranged like this in our plane, and we are trying to see if this function can actually solve this problem or not. And that is what shattering is like. And this kind of shows like if a line can shatter 4 or 5 points, it doesn't like shatter 5 points at all. Like it's not possible to do that.
It
It
doesn't
might.
even do for 4 as well.
Four you could classify. No, no, no. There
Yeah,
is
it won't. It
no,
won't.
no, no.
If we
The
are
thing,
having opposite classes,
yeah, yeah, yeah. The
and
thing is, see,
diagonally, and yeah,
yeah, yeah. You cannot classify two of these, right? Yeah, you cannot classify two of these using the line. That's true. But three you can do because we just like did that.
yeah, 3 we can, but 4 we cannot.
Yeah, four we cannot do. So for four, we cannot classify like these two or like these opposite two. Yeah, those are the ones that we cannot do. That is true. So what we are trying to do here, all I'm trying to say is that however many points that this function can shatter is the VC dimension for that function, for that classifier. That is the VC dimension for this classifier. So this line can shatter like 3 points. So a hypothesis with H1, H2, and H3. So that is the VC dimension of this function. So that VC dimension is 3 because it can do 3 points. That's it. So Bhavesh, does that make this part clear? Like this, what I've written here? Okay, good, good, good. So Let's quickly. I'm gonna export this part.
I have a question. I have a question.
Yeah,
Like,
yeah.
where do we use this VC dimension? Like, what conclusion? Or we
Okay.
just got to know that these points can be classified by this line or
Yeah,
this equation. That's it.
yeah.
But
Okay.
we never deal with like these many like three or four or five static
Mm.
classes. We deal with more when we are doing with that.
Okay. The first thing that VC dimension can help you with is selection of model. Selection of model. Because imagine if you're trying to classify something and all you do is like find a linear regression between them, which is a simple line, and it cannot even solve your problem. So linear regression cannot solve certain problems. So you know that if there are more than 4 or 5 results, in that case, a regressor is not something that you want to use, specifically linear ones. So selection of model, VC dimensions are useful to check. And then there is also this part that, this is like inherent part of this first point actually, to actually check, to actually check if an algorithm even solves your problem or not, even solves your problem or not. This is the important part. Like, if you have selected a specific algorithm and you have like a certain problem that you want to solve, and that algorithm is just not compatible with the amount of results that you can have, then it doesn't make sense to use that algorithm. And VC dimension just straight away tells you that it is kind of a technique to analyze your algorithm versus problem. So algo versus problem analysis. Uh, yeah. So that's what we are trying to do. We are trying to analyze if our algorithm is going to be able to solve our problem or not. So does that make sense?
So I just want to know that the
Yeah.
points to which we are classifying, those are our model. What they are classifying? Is it something like that?
What we are
If we are
classifying these points,
yes.
these points are our results. Like, think about this first problem, first thing that I had written. Like, you can go left or right. You're making a decision, and then you end up with these H1, H2, H3, and H4. Those are the results. That is what those points are. Any possible result that you can end up with.
Yeah.
Yeah,
Then I got that these are the results ultimately, right?
yeah,
But
yeah.
then how we are finding that this is helpful in our model selection of model, that how we are selecting on the basis of this. Can we have an example, like
Okay,
how we are saying that this model is good for it or not?
okay. So let's do
Selection.
it like this. 1, 2, 3. Obviously, a circle. So we had a question in the first assignment which was asking like about a circle in the at the origin, and
Origin sector
that one,
circle.
yeah, origin centered circle. So that one cannot classify these 5 points at all. But if you can move the circle around, then you can definitely classify this in a sense, in a way where you can arrange it in a certain sense. So imagine if you were to like create an ellipse of some kind, a function which creates an ellipse to get these two, or some kind of ellipsoid shape which selects these two opposite ones, or these two, or these two, which means that you will need that complex function, a function complex enough to create certain shapes. So shapes like these, or shapes like these, or even like just circles. You want a function that can create all of these shapes to be able to classify these 5 points. And if your function cannot do that, if your function cannot classify these 5 points, then you need to switch your function away from like that. So if your function was just going to be y is equals to mx plus c, and it doesn't work, then you have to move on to higher order functions. So you check the VC dimension of this function using these points, and then you move on to the higher order functions, and then check again, and then you move on to the higher order function. If you go too high, by the way, without checking, like imagine if this was solvable with an equation which was like say goes up to the fourth degree, like x to the power 4 or something, and you ended up using x to the power 8, then that is what an overfitting is, and that requires a lot more computational power. So this is more computational power. Computational power. And you do not want to waste that either. So you want to find something which is exactly useful, like exactly useful for us. So that's what you want to find. This is what you want to find. Does that make a little bit more sense? Yeah.
Yes, and where our model is like this equation is a normal equation. We are just checking that it's a VC dimension or not. Not what VC dimension it is. Okay.
Oh,
So my question is that how we are comparing it with our model, like learning model, what model
okay.
like we have said, na? How we
Yeah.
are setting this thing with our model. How we are
Uh,
selecting
this okay. So by the way, keep your mic on by the way for a second. Uh, this equation itself is a model in a sense. Does that make sense to you by the way?
it. Yeah, then it will be yeah, okay.
Because
Yeah.
this is a classifier, right?
This is a classifier.
Yeah.
Linear classifier.
And
Okay, linear
yeah.
classifier or a
Yeah, these functions that I'm talking about, these are all models. These are in fact models. These functions are just a way of saying that these are like very. I mean, this literally just you create a line to classify to find a result from an input. That is what it does. So these functions you can call them a classifier or models. That is exactly what these things are. That is the best way to like kind of explain it. So
okay, got it.
yeah, okay.
Earlier, I was thinking that this line and these things are something different, and we have models
No,
or
no,
something.
no, no.
But
It's just that this line is the model. Like this line is created because that is how we have trained the model to create that line for that specific input.
okay.
Okay. So, any more doubts on this, by the way? Like for anyone? Like, don't
Can you
hesitate.
go to that slide where you define that VC dimension? Just you wrote something maximum.
Oh yeah, we see dimension,
Yes,
highest
yes.
number that can be classified or shattered using a function. So this can be function or a model, or what else did we call it?
So just one thing I want to say that you initially told that H1, H2, H3 these are the hypotheses.
Yeah, yeah.
Hypothesis means
Part of
those
hypothesis.
possible solutions
Yeah,
that can define some function or something, some solution for all the data points or the test data that we have,
yeah,
right?
yeah,
And then we will just find which one is the best, which is predicting all the data sets which we are having. So we
yeah.
will say okay, this one can be the best solution for us, and we will predict our things with this particular hypothesis, right?
With
So
this particular classifier. Yeah.
this,
I
like,
mean, we
all
predict
these
the.
hypotheses are the solutions, right? And we are just selecting the best solution
Yeah,
out
yeah,
of,
yeah, yeah, yeah,
right? So
yeah.
now you are classifying these hypotheses with the
Uh,
help of some
yeah,
function like maybe linear or what you were talking. So
yeah.
shattering is like you are uh, dividing the hypothesis,
Yeah,
right?
basically, shattering is like saying that I want to be able to select every single combination of results. So if I want to select just these two, I should be able to select it using that specific function. So, or the classifier. Or like if I want to select these two, then I should be able to select it using the same function.
Mm.
Or if I want to select just this one, then I want to be able to select it using that same function as well. Just that one.
So that should, like, my mind is also going in that direction. The
Hmm.
guy who asked the question, like, why, what we'll achieve by dividing these hypotheses, like
Okay, so let's quickly talk about an example. Yeah, that's a. I mean,
the solution that you told that it will help us to find out the which one is the best model. So
yeah,
all these are the models actually, right? And we
the
are just trying
functions.
to find out the best model out of
Yeah,
these.
yeah, the functions. Okay, so look at where is that part? This part. I mean, this you have created a line, a circle, and this. These are all like lines representable by a function, right? and even these ones representable by a function, right?
Yes,
We
yes.
can graph them. Yeah, so we can graph them, right? So think of this very much graphically. Those functions that we use to write these, these specific lines, I'm calling them functions. We can also call them classifiers, or we can also call them, what else was it? I keep on forgetting. Like, there is so many names: functions, models, or classifiers. So
Model.
we can call them models as well. So that is exactly what I'm talking about here. Like, can this line give you all the possible results in here? Now let's talk about where this is useful. Like, where exactly this is useful. Let's talk about DNNs. Imagine that you are trying to identify an image, and I'll make two images where there is a sun, and there is a sun over in this, and there is a sun over in this image as well. And this is like a gross simplification of what I'm trying to show. So, like, there we go. There's a house in this one, but there is no house in this one. Makes sense. There's a tree in this one, and there's a house in this one. These are the two images that we're trying to classify. Now the thing is, you might have a neuron which just kind of tells you that there is a sun. So this is the neuron that kind of keeps track of sun, and that is just how it ended up training. Like, just hypothetically speaking, this is how it ended up training the model, where this neuron just kind of keeps track that there is a sun or not in the image. So for both of the images, image one and image two, both of these will give this neuron to be a high activation. So it will come out to be true that there is a sun here, right? Makes sense so far? Yeah. Now imagine this one is there to just check if there is a, this neuron is there to check if there is a house and not a tree, by the way. Just going to check if there is a house and not a tree. So this one, for this first image, image one, this will come out to be true. And for image two, this neuron will come out to be false, right? And this is like a gross simplification of the whole concept. But what is happening here is, imagine if there were like two more objects that this DNN can tell. Say there is a river, it can tell. So there is a river, it can tell. There is a mountain that it can tell. And let's just go with these four things. So house, tree, river, mountain, and sun. That's all it can tell between these things. So in this one first image, somehow it has ended up using hypothesis one, which is like, for image one, this came out to be true, and hypothesis two. So I'll just, like, one, two, three, four, five. One is sun, two is house, three is tree, four is river, and five is mountain. Yeah. So the first image has like used these two as a set. Makes sense? These two results as a set. The second image hasn't done that. It has done H1 and H3 instead. So this image is made out of two things, two results, which is a sun and a tree. So that is H1 and H3. And the first image is, H1 and H2. Does that make sense? Okay, good, good,
Mm,
good. So this is what we want to do. We want to be able to select individual things, results, these individual results, we want to be able to select them, but we also want to be able to select multiple of those, which is why we want to find out if our current function, which is telling that this is house, that is tree, that is sun, can actually, find out if there is a sun on the image, as well as there is a house on the image, or if there is also a tree on the image. So we want to be able to say that, okay, so there is a house and a tree, sorry, house and a sun in the image, then it will be like classifying in this upper direction. So these two are classified. And otherwise, like, if it is a sun and a tree, then it will classify in this direction where the house does not exist. Does that make sense? Okay, good.
okay.
And this line is what we are talking about. This is the classifier. This is also the model. This is also the function, or I don't know what else you can call it. But I was just complaining earlier in the group that machine learning somehow there is there are too many names given to too many things too many times.
Yeah. One more thing, like
Yeah.
the function we used to select, that used to
Mhm.
have a single line or a single
Yeah.
single structure, right?
Yeah.
Wherever it has to go. But in this case, it is getting changed as we are changing the requirement.
Yeah. Let's also quickly talk about, by the way, what kind of classifiers can exist. So you can have a classifier which is a straight line, right? That is linear. There is rectangles as well. Like you can have a rectangle, and that is usually called an axis aligned rectangle. Axis aligned rectangle. There are multiple regression lines that you can use as well, by the way. So, but still linear, by still linear. Curves, you can use curves for this classification. You can use circles, but those circle can be like either origin centered, or you can have a circle which is like just somewhere out in random, that kind of thing. And that is pretty much like all the classifiers that you can use. And by the way, this looks very much two-dimensional, right? This is like two-dimensional graph everywhere. But this line can also be a plane, like in higher dimensions. So in 3D, it could be a linear, can just as easily be a plane. And in higher dimensions, so 4D, 5D, sorry, 4D and 5D can be a hyperplane. Hyperplane. So nobody's stopping you from doing that. You can have a cube, obviously, in higher dimensions, so 3D cubes, or 4D, you can have tesseracts or hypercube, whatever you want to call it. For this, you can have just like a surface, I guess. For circles, there can be spheres, obviously, and hyperspheres, ellipsoids, ellipses, everything is possible. So yeah, but usually you just represent it in two dimension. That's all you have to do. So doubts on this one? The questions were great, by the way. Like, as long as you can exactly tell me what is confusing you, I'll like, try and like just solve that problem. So I mean, we have like 7 minutes remaining. Pointless to start linear regression today. I'll quickly export this and then I'll send this in the group as well. So exporting this and hypothesis, VC dimension, desktops. Save. There we go. Yeah. So let's end the class here for today, and tomorrow we will do linear. Let me check the what's remaining. So hypothesis evaluation, kind of same thing as VC dimension, and okay. And so bias variance trade-off and regression are remaining primarily. These things might have like smaller topics that I will actually have to check the video and see, like if sir has like specifically taught something very specific, then I'll also check that. I've already started checking the videos. So yeah, don't worry about if we would skip anything or something like that. But tomorrow we'll do bias variance trade-off and regression. Bias variance trade-off will kind of, it's not that we haven't started it yet. We've already started it with this whole concept. It's part of this VC dimension thing. So yeah, let's do that tomorrow. Any other doubts or anything you guys want to add to it?
Yes,
Okay.
but,
Yeah.
bro, can you scroll down?
Scroll down.
I, yeah,
Okay.
yeah.
Over here.
Like whenever we are having a classifier,
Yeah,
we
yeah.
used to have a single straight line.
Yeah, yeah. Not always.
Without,
Not always.
no, no, I'm just saying like for a linear one.
Yeah, yeah.
And we fix its position, right?
Yeah.
But in all these four cases, our
Hmm.
data is our hypothesis at the same place. So
Hmm.
as our hypothesis is changing, their values are
Yeah.
changing. We are changing our line.
Yeah.
So
So what's happening is like in this function, if you think about this y is equals to mx plus e, that's a normal line, a function which represents a line. M is kind of telling you how slope, what is the slope of this line. It is kind of telling you the degrees of that line. Like if it is like straight, if it is this way straight, or if it is like diagonal like this or something like that, that is represented by M. And C is kind of an offset of how far away from the origin the line is. So
exactly,
this
I get that.
function like
So
kind
the
of,
whole equation will be like if the 2 points are there like this, then we
yeah,
have to follow this line, this equation, and if the 2 points are different, then we have to follow this equation in this way. It will be like that model.
Usually for okay, so there's also one more thing. Usually when we are talking about VC dimensions, and we are like we distribute the H1, H2, H3, H4 on the plane, we try to do it most uniformly as possible. Like so, if you trying to like distribute three of them, you will just make an equilateral triangle kind of like that. If you're trying to distribute four of them, you will just create it like this. So as uniform as possible. So yeah, similarly, the line will go through that, and you can kind of classify that in a way. That is also one thing that you have to kind of keep in mind. And the line will actually, the line kind. Oh, let me go on Chrome. Fun thing, by the way. Practicals are always good. So Desmos, graphing calculator. You guys should like play with this one if you guys want to. Y is equals to 0.5 x plus 1. Okay, there we go. So let's look at that. If I were to create 4 points here, let's see, can I create 4 points here? Can I insert a table? X comma y, not possible. Oh, I can create a table using this table. So say that is 2 2 3 3 4 4 5 5. Nah, that's not good. Let's do 1 2. That's good. Okay, 2 1 and 1, delete 1. There we go. 4 points. Next time, there we go. So we have these 4 points visible, right?
Yes, yes, visible.
Okay, good, good, good. Now I will try and change this line. That's it. So plus one, there was plus one. So let's make it 0.2. There we go. This one is classified. The one below and above three, both of the cases are done. 0.7, that is two above, two below. 0.9 is not 1.2. 1.2 classify as the one above. And if I change this like negative 0.5, then I can go in this direction and start classifying in that direction. So let's say 2. Nah, 2 is too much. 1.7 is there. Like 1.7 classifies like this point, and 1.9 would be like 2.
2.25.
4. Yeah, 2.4 classifies two of these, but 2.7 would classify this
And
one single point.
can you check that thing? What we are doing, we are just changing our slope and our values.
Just the offset. We're changing the C offset, and slope I created like negative instead of positive. So if a positive slope, then it will be like this. If it's a negative slope, then it will be like this. Hmm.
So, what kind of a classifier is it?
That's a
Where we
linear.
are, matlab, it's a kind of a where we are having the output. We are
Yeah.
trying to get the slope and
Yeah.
not the intercept.
Yeah. We're just changing the M and C, and we're just like, kind of classifying these 4 points linearly. That's like literally it. What? Like that's literally a classifier right there. Although like this is not automatic like machine learning, but that's how the classifier is supposed to be. And by changing this equation, just by this linear equation being changed a little bit, we can classify all of these points. So you can definitely like the I think your question was this equation is changing between these lines, right? So that
Yeah.
equation is still the same function. It is still the same function, except these constants m and c, these are changing, and that is very much possible for this.
And which algo will be learning this thing? Will we be
Uh,
using? How will we sustain means? How will if we won't be doing it on manual basis, right? The code
wait.
line.
Can you repeat that? Like that was like the volume was very low.
I was asking that on what base, what like we are when we are predicting or classifying x and y.
Yeah.
Like this, we were using like linear
Yeah. This line is
with
linear.
yeah. But how
Yeah.
can I ask? Let me frame.
I mean, हिंदी में चलेगा, कोई दिक्कत नहीं.
मतलब मैं पूछ रहा हूँ कि जैसे ये लाइन है ना, अभी
हाँ.
हमारे पास जैसे डिसीजन ट्री या फिर सॉरी क्लासिफिकेशन के लिए और ये
हम्म.
linear
हाँ
लॉजिस्टिक रिग्रेशन का क्लासिफाई करने के लिए हमारे पास हमें पता है कि कौन सी एल्गो है, तो उसके बेस पे हम लोग कर लेते हैं, राइट?
हाँ
सो this time we have to get what intercept and what our slope will be, right? That we have to predict for for classifying these
that is like your result. That, I mean, that is the model's issue to like find it out. You don't have to do this part manually. All you have to kind of tell
yeah.
is,
So what,
yeah.
how is it being done? Who does it?
Okay.
Which
So
algorithm
all
is
you have to do here is check that for all values of M and all values of C. So this is C and this is M, right? For all values of these, is it possible that somehow I can classify these 4 points with all of their subsets? So can I classify these opposite points and these opposite points together somehow? That is obviously not possible. So yeah, you just have to like kind of tell that, with this, all the values of M and all the values of C, if it is possible to classify or not. If it is not possible to classify, then it doesn't shatter. If it is possible to classify, then yes, it shatters.
and till what so okay, like we have जैसे हमने एक लाइन से इसको कर लिया क्लासिफाई, ठीक
Mhm.
है, चलो
Mhm.
now अभी क्या हुआ, थोड़ा कॉम्प्लेक्स है सिस्टम हमारे पास, so we try to classify it by using rectangle or a circle, uh,
Yeah,
if it goes with the curves. So if we go with the curves, so every combination will be classified
yeah,
in that case.
yeah. So I do not know कि ये ellipsoid का equation क्या है, और this one shape जो मैंने बनाया था ना, कहीं बनाया था अभी, कहाँ चला गया, ये वाले शेप का मुझे इक्वेशन नहीं पता है. तो द इशू इज कि इफ आई न्यू द इक्वेशन ऑफ दिस, आई वुड एक्चुअली ड्रॉ इट एंड लाइक क्लासिफाई दीज एज वेल.
So in
एंड
that
देन
case, what I'm saying is everything will be shatterable in that case.
या
Like if we take an example of circle also.
या
For 2D, it is enough to classify or shatter everything, shatter every.
not really, not really. So even with circle you cannot classify certain things. So 5 points cannot be classified by a circle. So if you have 5 points like these, you cannot classify using circle because you want this point and this point together, not possible. So yeah, opposite ones like not they're not possible.
Ellipse. Okay. Curve,
Even with
not
ellipse also.
ellipse. What the figure you were saying
Yeah,
that
yeah,
you
yeah, yeah.
not
This
if I'm
one,
doing
like,
the yeah.
yeah,
This one will be, I think, working for all.
yeah, yeah. But that's the thing. This figure, like this one, would be like very complex to write. So let's look into the ellipse equation of an ellipse. That's the equation of an ellipse. And how do we bend it? I have no idea. So if I were to like write this down, x2 by b2 by x square by b square, I guess. X square by b square y square by a square, and I will remove this part and add sliders to all. So look at that. But I cannot offset this. Wow. B and A. Can I change X and Y? I have one. Okay, let me try and offset this using this 0.5. Nah.
नहीं, इसको सेंटर से हटाना है क्या? इस,
हाँ, सेंटर से
what,
हटाना है.
इसको प्लस में लिख दो, इसके कुछ भी अमाउंट लिख दो इसके साइड में,
Okay,
प्लस कर दो,
+2.
प्लस
Nah, didn't happen. Wait, hold on.
एक्सप्रेस where is it?
Plus 0.5.
No, it was something else. What was that?
ना, वहाँ से मूव तो नहीं हो रहा है. Should
इसको
I do
लिखना पड़ेगा.
हाँ, y +2? Not possible. Y +1, y plus 0.5. Nope.
This
Just
one.
can't move it. So हाँ, ये kind of like that. Center से हटाना circles को, it's a very big headache. And even creating that thing, by the way, rectangles
ये
are
वाला
not
ट्राई करना, x+1 का होल स्क्वायर y+1, इस तरह से कुछ है.
okay. X +1 का whole square कर देता हूँ.
या फिर मेरे को ओरिजिन सेंटर्ड और अनओरिजिन सेंटर्ड।
हाँ यार, ये हो गया. Yes, it got moved. So -1 and y -2. There we go. Very much possible. Can we tilt it by the way somehow? So with this equation, you can definitely classify these, I guess. Yeah. So see, this is like very much fun if you like try to do it with Desmos calculator. You can definitely like explore all of these. I would love to tilt this though a little bit. Like, how do I tilt this? Oh, let's try a like this one. A plus. Ah, that's not the one. Let's try B, I guess. Nope. Anyway, yeah, that's that. So try it, I guess, and have a little bit of fun as well. And yeah, I have to send these notes as well to you guys. I'll quickly send this 1 second.
I got that tilted slip.
Mm.
Oops.
Wait, till where?
I'm sharing.
Okay. So आज की क्लास
रिकॉर्डिंग चल रही है क्या?
प्रसन्न चल रही रिकॉर्डिंग? अच्छा, हर्षल के पास भी रिकॉर्डिंग है, प्रसन्न के पास भी रिकॉर्डिंग है, आई थिंक.
अभी
अच्छा
बंद हो गई है।
ओके
हाँ, नहीं बस मैं यही पूछ रही थी, अभी बंद हो गया ना तो ठीक है. जस्ट आशुतोष, जस्ट एक एग्जांपल लेकर देखें कि जैसे कि तुमने बोला ना लीनियरली वी हैव सम पॉइंट्स लाइक 10 डेटा पॉइंट्स, ओके,
हाँ हाँ
और उसको हमने मॉडल बनाया, लाइक मेरे पास 2 या 3 मैंने लाइंस क्रिएट की जिससे मैं उसको प्रिडिक्ट कर पा रही थी, मतलब वो मेरे डेटा सेट पर फिट हो रही थी.
हाँ
लेट्स टेक एन एग्जांपल ऑफ 3 लाइंस, ठीक है.
हाँ
अभी मैं बोलती हूँ कि जो VC डायमेंशन है, VC डायमेंशन इज कि किसी भी फंक्शन का VC डायमेंशन होगा, ठीक है, मैक्सिमम नंबर दैट कैन बी शैटर्ड, राइट.
हाँ, यस,
बोले तो कितना मैं उसको मतलब
क्लासिफाई.
हाँ, मैक्सिमम नंबर ऑफ पॉइंट्स दैट मैं क्लासीफाई कर सकती हूँ, ठीक है. अभी क्लासीफाई किसको कर रही हूँ? ये जो मेरी 3 या 4 जो भी मैंने लाइंस बनाई हैं, राइट, उसको मैं H1 H2 H3 H4 बोलूंगी, राइट.
यस, रिजल्ट्स फ्रेंड्स.
अब आई डोंट नो, बट तुम्हारा वो वाला एग्जांपल आई अंडरस्टूड, लाइक जो हट का था, सन का था, बट स्टिल मतलब मैं ये नहीं समझ पा रही हूँ कि ये जो मैंने 4 लाइंस बनाई है ना, तो इन चारों में से कोई एक लाइन ऐसी होगी जो मेरे सारे पॉइंट्स को फिट कर देती होगी, जिसको मैं मान लूंगी ओके चलो ठीक है, ये वाली लाइन मेरी सबसे ज्यादा मैच कर रही है, मैं इससे ही आगे का प्रेडिक्शन करने वाली हूँ, ओके. तो अब इन 4 लाइनों को मैं किसी भी मान लो सेंटर्ड सर्किल है या फिर मेरा पैरेललोग्राम है या फिर जो भी लाइन है, उससे डिवाइड करके मैं क्या अचीव कर पा रही हूँ, लाइक प्रैक्टिकली मैं सोचने की कोशिश कर रही हूँ. ये एग्जांपल मुझे समझ में आया जो आपने बोला था, ये हट वाला. इस एग्जांपल में आप समझ पा रहे हो क्या, लाइक व्हाट विल आई अचीव?
एक एग्जांपल लेते हैं जिसमें 2-3 मॉडल लेते हैं और हाइपोथेटिकली 2-3 मॉडल लेते हैं और उसको एक समझाने की कोशिश करते हैं कि कौन से मॉडल को हम सिलेक्ट करेंगे किस कंडीशन में.
मतलब ये क्या
बाय यूजिंग VC डायमेंशन
डाउट है क्या जो मेरे माइंड में आ रहा है, या बस मेरा ही डाउट है ऐसा? मतलब
नहीं, मेरे को भी है वाली चीज. कोई समझना है कि ये कैसे हम लोग VC डायमेंशन को यूज करके किसी एक पर्टिकुलर मॉडल को हम सिलेक्ट कर ले रहे हैं और एक को रिजेक्ट कर दे रहे हैं. Okay. For that we need to have 2 models so that we can compare.
Acha, Ashutosh.
Yeah.
I have another question. So you said that these hypotheses are just set of solutions which we have to individually classify.
Yes.
So here, So here we have 2 variables, right? X and Y, and we can take 3 variables. So we are able to visualize that. So we are able to say that okay, a line can maximum classify a set of 3 points. But
Yeah.
above three dimensions, how can we say that a function, my function is able to classify all this set of solutions individually or separately?
Hmm. Okay, so imagine in 2 dimensions, you can have things being separated by a line, right? So far, like, you agree with me?
Yes.
Okay. So what is the shape that will be like useful in like 3 dimensions, uh, which can separate two things? So imagine there is a, you know, over here, and over here. I'm going to like create a line like this. Uh, it would be like somewhere around here. So there is an object over here, and say there is an object like over. Shit, I can't really draw for some reason. There we go. And then I'll just go ahead make it same height. And the other object is over here, right? So what can separate these two objects from each other? What kind of shape?
Uh, a plane.
Exactly. So in that case, you would require a whole plane that will go like this, and it will separate these two. And there is a proper function for plane as well, by the way. It's not like the functions don't exist for planes, they exist for plane as well. So this would be a classifier in that case. That would be our function, classifier, or model, whatever you want to call it. Make sense? And also, does that even like what that was your question, right?
Yeah, but what I'm more concerned is key about these three dimensions, how we cannot visualize anything, right? So how
Oh,
can we definitively say that my function is able to classify all the solutions?
oh, just that. Okay, so it's not that you cannot. Okay, weird thing happens when you go over like 3 dimensions, but it is not that you cannot visualize it. You can visualize high dimensions. uh, why am I even writing this? So you can visualize high dimensions. It's just that it's a different method of visualizing it. You have to project it down to lower planes. You have to like run certain different kind of analysis on it to be able to tell key this is what kind of effect it is having when you turn something or twist something in higher dimension. So yeah, you can actually visualize it. It's not that you cannot visualize it. And even if you cannot visualize it, there are certain properties of geometry that still applies to higher dimensions as well. So 4 dimension, 5 dimensions, those geometrical properties do not break. So you can like extrapolate and kind of think about it that way. So yeah, even in higher dimensions, it works perfectly fine. It's just that once you start working with higher dimensions, you should be able to like visualize it a bit better. It's just that you cannot do that directly without any guidance or experience. Yeah, makes sense.
Yes, yes, yes. Thank you.
Okay.
Thank you. I will keep it.
Okay, so back to the question that was asked by Gitika and Riyansh, right?
Yes.
Okay, चलो एक अपन है ना प्रॉब्लम देखते हैं. So the weirdest thing about all this VC dimension thing is that you remember in when I was teaching these neural networks like 1, 2, 3, let's make those right. These, uh,
Yes.
yeah. So this right. There are weights here, right? Weight 1, weight 2, weight 3, weight 4, weight 5, weight 6, and then there are like you're supposed to get say that I'm going to make two of these. You're supposed to get these outputs. From here, you get a single output, right? So, primarily, what you are trying to do is, aren't you trying to like go in this direction and then in this direction and give some component of like this into this after going through this layer and this layer, and then some component of this going through this layer and then this layer into this as well, like you're trying to do that, right? Agreeing so far? Okay, good. Now, all I'm saying is what if the function that I'm using, this one is a linear function, by the way, definitely a linear function, because we do weighted sums, right? So w1 x1 plus w2 x2, that kind of thing, right? Weighted sums and then minus bias, and then we do a sigmoid function after that. So that exists there. Then, but this is a linear function. This is exactly what a linear function looks like. Y is equals to mx plus c. Mx is w1 x1 and plus c is minus b basically over here, or you can do plus b definitely. So this is what a linear function is. Now with how many variables, so how many w's and x's, w how so x n and w n, what is the number of n that is supported by our equation? So over here the number of n is what? One. So there, that is one, two, three neurons, four, five neurons. There are five neurons here, and that is not like how many weights we have more weights than that. So six weights here, 7, 8, 9, 10, 11, 12, 13, 14 weights. In total we have 14 weights. So similarly we will have 14 different x1s and x2s and those kind of things, these, but there are only five neurons, right? All I'm saying is this number n kind of dictates what how many lines we have of classification. So imagine if we have two lines of classifications, that would be x1 w1 plus x2 w2 plus bias. This will be equal to some y, right? And that will create these two lines. That will create two lines because x1 w1 and x2 w2, those are two lines. And with those two lines, you can actually shatter these points, 4 points. So like this, all I am saying is, by the way, is can I reach using this equation? Can I reach all the outputs? Is it even possible to reach all the outputs? Um,
ये जो
all
4 पॉइंट्स आपने बनाए हैं, ये क्या है?
these are results. Result one, result two, result three, result four.
बट
With
वेट
this equation,
डायमेंशन तो
yeah,
शटर जो कर रहा है वो हाइपोथेसिस को कर रहा है ना,
yeah, and that is the result.
पॉइंट्स.
Yeah, and you write it like this, right? H1, H2, H3, H4. So these are H1, H2, H3, H4. Okay, okay. Think about it like this. Think about it. So let's back up a little bit, like over here. Let's go to like this part, and just think of it. If this equation can support four answers, can this support four answers? Is what I'm saying. If this equation cannot support four answers, which means that the W1s and W2s are not sufficient. We need more weights or more data to store actually actually all the turning points in our
अच्छा,
decision.
इसको ऐसे सोचे क्या, ये जैसे आपने y लिखा है x1 w1 x2 w2,
Yeah.
तो इट बिकम्स हाइपोथेसिस 1, राइट? इससे मिलता जुलता हम कुछ बनाएंगे, लाइक वेट्स में हमने कुछ चेंज कर दिया, एंड देन वी हैव क्रिएटेड वन मोर फंक्शन दैट इज लाइक x2 w1, मे बी y कुछ और ले सकते हैं, z1 w1 plus z2 w2, and that becomes the second function. So I have two options now, either I will go with this x1 w1 वाले से, उससे मैं
Yeah.
किसी आउटपुट पे पहुंचूंगी, एंड आउटपुट मीन्स आई हैव अ टेस्ट डेटा, ठीक है? तो उस पूरे टेस्ट डेटा पे ये वाला फंक्शन मैं अप्लाई करती हूँ, एंड इट गिव्स मी लाइक ये ट्रेन हो गया मेरा उस टेस्ट
Yeah.
डेटा से, जो भी है ट्रेनिंग डेटा से. उसके बाद एक सेकंड फंक्शन मैंने और बनाया है. सो दीज आर लाइक माय हाइपोथेसिस 1, देन अदर वन इज लाइक हाइपोथेसिस 2. तो अब मैं इसमें से कोई एक चुनती हूँ, दैट बिकम्स माय मॉडल, राइट? तो अभी मैं जो डिवाइड कर रही हूँ वो डेटा को डिवाइड नहीं कर रही हूँ इस लाइन से. आई एम ट्राइंग टू डिवाइड hypothesis that
You're
were
trying to divide all the resultants.
right.
Yeah. Okay, so look at it like this. Look at it like this. ये हमारा एक decision tree है जहाँ we ask one question over here, then we will ask another question here or over here, right? And then you will like make another two decisions. True? Decision tree में ये sense बना रहा है? Good. Okay, good. So when you create this decision, right? This decision on question 1, that can be stored in W1. That is a variable that we have available that can store either true or false. So it can go either this way or it can go this way, and that can be stored with just one variable. True? So far, makes sense? Similarly, if this question 2 is same as this question 2, then W2 will be able to store this decision as well, right? W1 stores this decision and W2 stores this one, this level decision.
On the basis of W1 decision, right?
Yeah, if W1 is true, then it will ask this question, which is the same as this question. So XOR gate example. So example of right. So W2 will be able to store whatever decision is being made on this level, right? True. And how many results does it lead to? It leads to 4 results. With just W1 and W2, it leads to 4 results, which means this equation can handle 4 results. It can classify 4 different kind of results. Does that make sense? It doesn't mean these four, by the way. Let me show you exactly what 4 results it can handle. The first result that it can handle is just this, where it is classifying this. The other one, this, where it is classifying this direction. The other result it can handle is it is classifying none of these. Or the other result it can handle is it is classifying both of these. So this one. These are the 4 results that this whole decision tree can handle. And just by these two, W1 and W2, by storing some value in W1 and W2, you can recreate these results. You can recreate going it out down this direction and then this direction, or this direction and then this direction, and you can recreate that with W1 and W2. So these W1 and W2, it doesn't allow for all of our outputs. So like I said, in this one it allows W1 W2, like allows for these 4 outputs, no issue. But what if we had one more decision over here? What if we had like what if the tree looked like this? If this was the like first level, this is W1 level, the question 1. This is the question 2 level where W2 gets stored. And then there is a W3, like there is one more question after this for the classification. So this makes 8 possibilities, right? So this is W3. So we need this W3, and the VC dimension is all it is telling you is if your function. So for linear one, it is very easy to tell that you have x1 W1, x2 W2. You can easily tell that these many lines will be there. But for complex functions, it is very hard to tell directly by looking if our function will have certain shape, or what kind of graphing it would have, or would it be able to classify these 8 different things together somehow. So yeah, that W3 is required in that case. So our function is no longer compatible with our hypothesis. So it cannot shatter that hypothesis, which means that we need to get a better function which can classify our problem in a better way. So W3 will allow us to do like 4 more classifications. That's what's happening. Like we reject this because this does not support like the 3rd level of decision. Make sense? Does it make sense? That feels like it doesn't.
अच्छा, कहीं मैं हाइपोथेसिस गलत तो नहीं सोच रही हूँ ना? आप कह
Just
रहे हो ये जो 8 रिजल्ट्स जो आए हैं, that you are trying to reach, and you are saying कि ये जो tree है, it is helping to reach till these 8 points, right?
Yeah.
So these 8 are what? Like each
These are
of my training data. Are you
no.
talking about that hypothesis?
No. This is like
What I'm thinking is hypothesis is, for example, मेरे पास 8 solution है इन 8 result sets को satisfy करने के लिए. So each solution will reach till the 8 solutions. Like 8 मतलब मेरे पास ट्रेनिंग डेटा सेट में 8 केसेस हैं. इन 8 केसेस को मुझे उस मॉडल में फिट करना है, right? So if I am having
as a result, huh?
Yeah, you said na, these are the 8 results, right?
Yes, these are the
So
8.
मेरा हर मॉडल इन 8 results तक पहुंचना चाहिए, right? That's what I.
Your model should be able to reach एक रिजल्ट इंडिविजुअली या मल्टीपल रिजल्ट्स, कॉम्बिनेशन ऑफ सर्टेन रिजल्ट्स की ये और ये एक्टिवेट हो जाए, चल जाएगा. बट वो
मिलता जुलता भी पहुंचेगा, कोई एग्जैक्ट पे पहुंच जाएगा, या 8 में से कोई सा होगा जो 7th रिजल्ट एग्जैक्ट देगा और 6 को little bit
थोड़ा
pass
सा
कर
एक्टिवेट
दिया,
कर देंगे,
right?
हाँ.
So that's what will be my nature of all the solutions. Like for example,
Yes.
I have found 5 solutions, तो मैं उन 5 को मेरे hypothesis कह रही हूँ. These are my 5 hypotheses. अब
नो नो
मुझे
नो नो, थोड़ा थोड़ा सा करेक्शन, थोड़ा सा करेक्शन.
हाँ हाँ
वो 5 जो है, दैट इज योर वन हाइपोथेसिस, लाइक दैट टोटल हाइपोथेसिस, वो हाइपोथेसिस ही है. ऑल पॉसिबल रिजल्ट्स इज योर हाइपोथेसिस.
but
सो
H1 H2 H3 H4 H5 किसको बोलोगे?
लुक, ये हाइपोथेसिस है, एंड
हाँ
दिस इज द सेट ऑफ H1, H2, H3, H4, H5. These are all the points of possible outputs.
H1
Think of
H2
these,
okay.
ये
I
outputs.
think हाइपोथेसिस तो अपन लोग फंक्शन को बोलते हैं ना, कि वो फंक्शन
Right, हाँ
जितने नंबर ऑफ फंक्शंस, जैसे हम लोग बोलते हैं लीनियर रिग्रेशन में, जितने नंबर ऑफ लाइंस के हम फंक्शंस बनाएंगे, so that many hypotheses we are having. So
Functions जो है, that is,
which one will be the best one, so we select from there.
हाँ यही मेरा भी अंडरस्टैंडिंग है.
look, so functions जो है ना, those are more likely to be called models या फिर classifiers. These are what functions are. Hypothesis के अंदर जो ये points है ना, that is what we need to classify. These are all possible outcomes. So this thing inside H1, H2, H3, these are outcomes or outputs. And this H, the collection, is the hypothesis. And what we are trying to do with, there is one more part of this, by the way. What we are trying to do is, when we try to shatter it, we try to, like, remember I said power set? So a power set is like null set. There would be like H1, just H1. There would be H2. There would be H3 individually, by the way. H4, H5, and then there would be H1 comma H2, H1 comma H3, and so on and so forth until it covers all the subsets, all the like subsets of this. And once you are able to, like, use a function, you can use a function, a model, or a classifier, same thing, to reach all of these outcomes, all of these subsets. That is when you shatter. Like, that is what shattering is. And primarily, by the way, with this example, all I was trying to say was that because there are 3 levels of decision making here, and we have only 2 variables to store it. It means that this problem will not be shattered. Like, if we try it on graph, this will not be shattered, or it won't be possible to be shattered. Which means that we need one more variable, x3 w3, to store w3 to store that last decision point. This level of decision.
हम्म
मुझे ऐसा लग रहा है ना कि वो न्यूरल नेटवर्क्स एक बार और पढ़ा दूं, क्योंकि दिस इज वेरी मच रिलेटेड टू दैट. लाइक, इट इज 100% रिलेटेड टू दैट.
इसका मोर रिलेशन हमारा हाइपोथेसिस,
क्या
मैं पूछ रहा था, इसका मोर रिलेशन जो मतलब जो रिलेशन है इसका किसके साथ है? इसका हमारा नॉर्मल मशीन लर्निंग के साथ है, जैसे हमारा होता है लीनियर रिग्रेशन, ये
इसका डायरेक्ट रिलेशन इज लाइक बेसिकली, आई टेल यू व्हाट, सभी मशीन लर्निंग मॉडल्स में या डीप लर्निंग मॉडल्स में यू विल फाइंड सर्टेन थिंग्स कॉल्ड वेट्स एंड बायसेस. इसका रिलेशन है कि द अमाउंट ऑफ वेट्स एंड बायसेस दैट यू हैव, ऑल द पैरामीटर्स यू हैव, पैरामीटर्स जो तुम्हारे पास हैं, is it the only thing it answers is it sufficient to solve our problem. कहीं ऐसा ना हो कि प्रॉब्लम इतनी ज्यादा कॉम्प्लेक्स हो कि हमारे पैरामीटर्स ही उसका डेटा स्टोर करने के लिए कम पड़ जाए. दैट इज व्हाट द वीसी डायमेंशन आंसर्स. अगर वीसी डायमेंशन में तुम्हारा प्रॉब्लम शटर हो गया है, तो दैट मीन्स कि तुम्हारे पास जितने वेरिएबल्स है, दैट इज सफिशिएंट टू सॉल्व योर प्रॉब्लम.
Now different definition, new confusion.
It is the same definition. I'm like, शुरू से लेके अभी तक है ना, it is the same definition. Start से लेके
Multiple variables, अभी ये वाली चीज अच्छे समझा भाई, अभी जो लास्ट में बोली.
ओके, यही वाली चीज मैं यहाँ पे समझा रहा था. लेट्स ट्राई इट अगेन. सो इमेजिन ये वाला हिस्सा है अपना फर्स्ट क्वेश्चन, क्वेश्चन नंबर 1, टू मेक अ डिसीजन कि हमें लेफ्ट जाना है कि राइट जाना है. क्लियर है इतना?
हाँ क्लियर.
ओके, नाउ टू स्टोर कि हमारे पास जो इनपुट आ रहा है, हम वी कैन कंपेयर इट टू अ वेरिएबल कॉल्ड W1 फिलहाल. ठीक है, W1 उसको हमने नाम दे दिया. वी कैन कंपेयर टू इट एंड सी कि हमारा इनपुट ये आया है तो हम लेफ्ट जाएंगे, और इनपुट वो आया है तो हम राइट जाएंगे. मेक्स सेंस यहाँ पे?
ठीक है, तो मतलब
है
डिसीजन
ना?
के लिए आगे.
तो W1 कैन हेल्प यू डिसाइड कि इधर जाना है कि इधर जाना है, एंड देन यू एंड अप ऑन द लेफ्ट हैंड साइड. है ना? एंड ऑन द लेफ्ट हैंड साइड देयर इज क्वेश्चन नंबर 2. सो व्हाट हैपेंस इज, यही वाली चीज हम इसी वेरिएबल में फिर से तो स्टोर नहीं कर सकते. है ना? कि अगर सेम क्वेश्चन होता, सेम क्वेश्चन इज बीइंग रिपीटेड, तो देन W1 कैन हेल्प अस ऑब्वियसली. बट इफ द सेम क्वेश्चन इज नॉट बीइंग रिपीटेड और ये किसी और इनपुट के बारे में है, तो वी विल नीड अनदर वेरिएबल टू स्टोर कि हमें ये वाला जो इनपुट यहाँ मिल रहा है, इधर वाला जो इनपुट है, इनपुट 2 या इनपुट 1 था जिसको हमने कंपेयर किया है W1 से, या इनपुट 2 जो है हमारा, इसको हम W2 से कंपेयर करके हम देख सकते हैं कि हमें लेफ्ट जाना है कि राइट जाना है. W1 से तो हम नहीं कर पाएंगे अनलेस क्वेश्चन 1 क्वेश्चन 2 सेम हो. है ना? दिस मेट्रिक टू आंसर की लेफ्ट जाना है कि राइट जाना है डिफरेंट है इस वाले में. क्वेश्चन इज डिफरेंट क्योंकि, है ना, बिकॉज क्वेश्चन 1 क्वेश्चन 2 इज डिफरेंट. तो यहाँ W2 यूज हो जाएगा. फिर क्या होगा, यू टर्न राइट, सपोज राइट चले गए. है ना? एंड देन यू हैव क्वेश्चन नंबर 3 टू मेक वन मोर डिसीजन कि अब यहाँ से हमें लेफ्ट जाना है कि हमें यहाँ राइट जाना है, लेफ्ट जाना है कि राइट जाना है. तो वी कैन नॉट, क्वेश्चन 1 इज डिफरेंट फ्रॉम क्वेश्चन 2 इज डिफरेंट फ्रॉम क्वेश्चन 3, तो हम W1 को रेफर नहीं कर सकते, W2 को रेफर नहीं कर सकते. वी विल नीड अनदर वेरिएबल टू स्टोर इस वाले डिसीजन के लिए. है ना? फॉर क्वेश्चन नंबर 3. तो दैट रिक्वायर्स वन मोर वेरिएबल. है ना? ये वेरिएबल्स जो है W1 W2 W3, ये क्या है, ये पैरामीटर्स है जिनको हम क्या करते हैं, बार बार डिसीजन ले लेकर यहाँ जाके हम ट्यून करते हैं अपने वो न्यूरल नेटवर्क्स में. है ना? एंड द ओनली थिंग यू नीड टू नो इज कि ये W1 W2 में काम हो जाएगा कि W1 W2 W3 भी लगेगा, कि या हो सकता है कि हमें 7 वेरिएबल लगे कि W7 तक जाना पड़े हमें. इफ देयर आर 7 लेवल्स ऑफ डिसीजंस देन ऑब्वियसली 7 तक जाना पड़ेगा हमें. दैट इज लाइक अ सिंपल एग्जांपल, छोटा सा. तो आर योर पैरामीटर्स इनफ, तुम्हारे पास जो वेरिएबल्स हैं डेटा स्टोर करने वाले, वो सफिशिएंट है कि नहीं अपनी प्रॉब्लम को सॉल्व करने के लिए. दैट इज व्हाट वीसी डायमेंशन में शैटरिंग टेल्स यू. अगर प्रॉब्लम शैटर हो गई है उतने वेरिएबल्स में उस फंक्शन से, तो इट मींस कि वो दैट फंक्शन इज गुड इनफ टू क्लासिफाई, टू रीच अस, लाइक टू पुट अस ऑन ऑल द आउटपुट्स. ये यहाँ भी पुट करेगा अपन को, यहाँ भी करेगा, यहाँ भी करेगा, यहाँ भी करेगा, सब जगह अलाउ करेगा टू गो कि यहाँ भी जा सकते हो, वहां भी जा सकते हो. एंड नन ऑफ दीज आर आउट ऑफ बाउंड, नन ऑफ दीज आर लाइक अनरीचेबल नहीं है इसमें से कुछ भी. है ना?
मेन प्रॉब्लम का शेटरेबल होना जरूरी है, राइट?
हाँ. एंड ऑल इट इज टेलिंग यू इज वो पैरामीटर्स शैटर हो गया, यानी कि योर पैरामीटर्स एंड फंक्शन, इधर फंक्शन इतना कॉम्प्लेक्स है कि वो शैटर हो गया है, कि वो अलग तरीके से इट हैज फाउंड अ वे टू स्टोर दैट काइंड ऑफ इंफॉर्मेशन. कि जैसे अपन ने बहुत कॉम्प्लेक्स सर्कल या एलिप्स बना दिए, है ना, या फिर ऑन द अदर हैंड पैरामीटर्स आर इनफ. जो ये W1 W2 W3 वेट्स वगैरह वी आर दैट वी आर यूजिंग आर मोर देन सफिशिएंट टू टेक अस टू ऑल ऑफ द डिसीजंस. है ना? दैट इज ऑल इट इज सेइंग. लाइक वीसी डायमेंशन का, लाइक शुरू से लेके एंड तक है ना मशीन लर्निंग में, इट इज अ theoretical थिंग दैट यू डेफिनेटली डू नॉट नीड. लेकिन इट्स ऑल्सो अ थिंग क्योंकि अपन को सिलेबस में है, तो शुरू से लेके आखिरी तक इसके कनेक्शन सब जगह दिखेंगे. लाइक इवन इन मशीन लर्निंग, डीप लर्निंग में भी मिलेंगे. परसेप्ट्रॉन्स में तो अपन ने लाइक वेट्स वगैरह तो हो ही गए. वीव सीन की वेट्स कैसे एडजस्ट होते हैं. है ना? So does that make sense so far? I'm like just hoping कि थोड़ा सा
हाँ.
सेंस इसका.
हाँ, आया है समझ में.
Okay. Just try to like connect it to अपन ने न्यूरल नेटवर्क्स जो किए थे ना अभी कुछ दिन पहले. If you connect it to that, you will realize कि वो W1 W2 W3 जो adjust हो रहा है, those are these parameters जिनकी बात कर रहे हैं. और all we are saying with VC dimension is कि क्या जितने पैरामीटर हमने लगाए हैं उतने सफिशिएंट है कि प्रॉब्लम सॉल्व करने के लिए.
Is it also helpful कि हमारी कितनी hidden layers होनी चाहिए, वो तो sufficient है या नहीं है?
अगर
बहुत
हमारे
बड़ा
पास मान लो चलो ये देखते हैं, सो देर इज वन टू इनपुट्स एंड देन वी हैव थ्री ऑफ दीज एंड देन थ्री ऑफ दीज एंड टू आउटपुट्स, राइट? सो लाइक इमेजिन हाउ मेनी वेट्स वी हैव यहाँ पे. देर आर लाइक 6 वेट्स यहाँ पे, देर इज लाइक 3 into 3 9 वेट्स यहाँ पे, देर आर 9 एंड देर इज गोइंग टू बी 6 ओवर हेयर, ये वाला एंड 6 यहाँ पे है ना. तो 12 and 9, that is 21 in total, right? You have 21 weights here, and most of the problems can be solved using this. Like most of the small problems, at least. अपन ने XOR gate बनाया था, OR gate, AND gate करने वाले थे, का किया नहीं. But those are like very much like possible with this. Like 21 is too much for it. Like with two inputs of AND gate or gate, you just need कितने weights? Two weights. Weight 1 and weight 2. So with just two neurons, so 1, 2, and one output, you can easily design a XOR gate. And that is like the most basic algorithm. जो सबसे बेसिक तरीके से अपन लिखते हैं ना कोड XOR गेट का, वो यही है कि मतलब वी यूजिंग टू इनपुट एंड वन आउटपुट डायरेक्टली बाय मल्टीप्लाइंग इट विद सर्टेन काइंड ऑफ वेट. बस हम उसे मैथमेटिकली नहीं करते हैं, हम इफ एल्स लगा देते हैं, बट यू कैन डेफिनेटली डू इट मैथमेटिकली एज वेल. काइंड ऑफ वियर्ड, लाइक VC डायमेंशन है ना, इट लुक्स लाइक अ स्मॉल थिंग बट वो शुरू से लेके आखिरी तक सब जगह है. But हाँ, it is also something that you can like go without learning about ever. Like इतना जरूरी भी नहीं है. तो और कोई डाउट इसमें? I mean कोई भी डाउट हो?
आपने पढ़ा कहाँ से, इससे कोई रेफरेंस बता सकते हैं?
ये सब I have, अब मुझे तो
कोई
याद नहीं
lecture?
कि VC डायमेंशन मैंने कहाँ पढ़ा था. There was this website यार, वो वेबसाइट का नाम भी याद नहीं. ग्रुप में पोस्ट हुई थी वेबसाइट.
आशुतोष, VC डायमेंशन समझ में आ गया, वो भी समझ में आ गया कि मैक्सिमम कितने पॉइंट्स डिवाइड हो सकते हैं, वो सब समझ में आ गया. द
हाँ.
प्रॉब्लम जो नहीं समझ में आया इज कि जस्ट वो भी एक एक्स्ट्रा क्वेश्चन ही है, इट्स नॉट रिलेटेड टू एनीथिंग, उससे कुछ होने वाला है. जस्ट वी वांट टू अंडरस्टैंड कि इसको डिवाइड करके व्हाट वी अचीव, बट व्हेन यू आर एक्सप्लेनिंग इट ना, तो कहीं कंफ्यूज हो जा रहा है. यू आर जस्ट सेइंग कि मुझे फॉर एग्जांपल इफ यू हैव टेकन दिस 8 output example, so you are saying maximum how many outputs I can achieve with that.
Yes,
But
with the
that is
amount
the
of
quality of that hypothesis, right? But here I am trying to divide the hypothesis कि मेरे कितने maximum hypothesis शटर हो सकते हैं विद दैट पर्टिकुलर जो भी फंक्शन मैंने लिया है, सर्कल लिया है या स्क्वायर लिया है या रेक्टेंगल लिया है. तो वो चीज मैं ना प्रैक्टिकली नहीं सोच पा रही थी, और शायद अभी भी नहीं सोच पा रही हूँ, बट इट्स ओके.
ओके एक बार और, एक छोटी सी चीज और
नहीं, बट बिकॉज क्या है ना, आप जो समझा रहे हो ना, वो आप फिर डेटा पॉइंट पे आ जाते हो समझाते समझाते. बट व्हाट वी आर डूइंग, वी आर शैटरिंग हाइपोथेसिस. और जहाँ तक मैं पढ़ रही हूँ ना, मैंने बुक थोड़ा पढ़ा है, थोड़ा बहुत 1-2 चैप्टर, तो उसमें वो जो हाइपोथेसिस बोलता है ना, वो हाइपोथेसिस एक जनरल फंक्शन को ही बोलता है जिससे मेरा जितना भी डेटा आया है, जितने भी रोज हैं मेरे पास डेटा की, मतलब जो भी मेरे पास सैंपल है, उसको वो सेटिस्फाई करता है. दैट इज माय हाइपोथेसिस. तो आई कैन हैव मल्टीपल हाइपोथेसिस, ठीक है. और VC डायमेंशन कहता है आई एम डिवाइडिंग हाइपोथेसिस. सो थोड़ा सा मतलब वही था, समझ नहीं पा रही थी मैं भी क्या कर रहा है.
स्मॉल थिंग, बस इतना याद रखना है कि ये जो लाइन है ना जिससे हम डिवाइड कर रहे हैं,
हाँ,
दिस इज द फंक्शन, है ना, क्लासिफायर, ठीक है, विच इज दिस फंक्शन. ये फंक्शन लिखा था मैंने यहाँ पे,
हाँ,
है ना. एंड ऑल दिस लाइन इज शोइंग इज कि क्या इस फंक्शन से, इस लाइन से, इस फंक्शन से कैन आई फाइंड ऑल दैट पॉसिबल डिसीजंस, कि ये वाला डिसीजन क्या मैं इसी लाइन से पहुंच सकता हूँ क्या इस वाले डिसीजन तक, या इस वाले डिसीजन तक, या इस वाले डिसीजन तक पहुंच सकता हूँ क्या, या फिर मैं इस डिसीजन तक पहुंच सकता हूँ क्या इसी फंक्शन से, बाय एडजस्टिंग दैट फंक्शन अ लिटिल बिट, है ना. और दैट इज व्हाट वी आर चेकिंग यहाँ मैथमेटिकली कि ये W1 W2 सफिशिएंट है कि नहीं इस वाले डिसीजन में पहुंचने के लिए, या इस वाले डिसीजन में पहुंचने के लिए, या इन दोनों में पहुंचने के लिए. W1 W2 इज सफिशिएंट कि नहीं है. तो यहाँ पे अपन के पास W3 की जरूरत और पड़ रही थी क्योंकि वी नीडेड टू स्टोर वन मोर डिसीजन। ये फंक्शन को अपन को और कॉम्प्लेक्स करना था, लाइक बाय एडिंग वन मोर लाइन यहाँ पे x3 W3 वी हैव क्रिएटेड दिस फंक्शन व्हिच इज मोर कॉम्प्लेक्स देन दिस फंक्शन, है ना। बेसिकली हो क्या रहा है, आखिरी में एक बार और बना देता हूँ। जो x1 W1 है ना, दैट इज दिस लाइन मान लो, ठीक है। जैसे ही हम इसे प्लस करते हैं x2 W2, तो इसका मतलब क्या होता है, देयर इज वन मोर लाइन नाउ। जैसे ही हम इसे प्लस करते हैं x3 W3, इसका मतलब क्या होता है कि देयर इज नाउ वन मोर लाइन, एंड नाउ वी कैन टेल कि ये वाला जो एरिया है दैट इज व्हाट वी आर ट्राइंग टू लाइक आइसोलेट, है ना। तो रेक्टेंगल कैसे बनेगा, ऐसे बनेगा रेक्टेंगल x1 W1 प्लस x2 W2 प्लस x3 W3 प्लस x4 W4, ऐसे बनेगा रेक्टेंगल। और कैसे बनेगा रेक्टेंगल, यहाँ पे मान लो ये वाली जो लाइन है इसको मैं बोल देता हूँ लाइन 1, इसको बोलता हूँ लाइन 2, ये लाइन 3 है और ये लाइन 4 है। तो ये मान लो लाइन 1 बनी, ये लाइन 2 बनेगी, ये लाइन 3 बनेगी और ये लाइन 4 बनेगी, है ना। एंड यहाँ पे जो बीच में जो एरिया है, बाउंडेड एरिया है, इसके अंदर आना चाहिए जो हमें चाहिए, है ना। दैट इज ऑल व्हाट वी आर डूइंग। तो
जो हमें चाहिए वो
अभी
हमारा
थोड़ा
output है।
लॉजिक लगा कि मैक्सिमम कितना मेरा हाइपोथेसिस था जो उसके अंदर आ पा रहा था, मतलब
हाँ
एक ही पर्टिकुलर डिसीजन को मेंशन कर पा रहा था, राइट।
हाँ यस। अगर ये वाला है और हम रेक्टेंगल कर रहे हैं तो वी कैन ड्रॉ अ रेक्टेंगल लाइक दिस एंड बी लाइक कि यहाँ बाउंड हो गया ये, और साथ ही में लेट मी क्रिएट वन मोर। इसके बाद में मान लो टॉप राइट वाला बाउंड करना था हमें, ये वाला करना है, तो वी कैन क्रिएट अ रेक्टेंगल ऐसे, है ना। एंड दैट विल लाइक ये बाउंडेड एरिया जो उसके अंदर आ गया ये क्लासिफाई हो गया। और इफ यू वांट टू लाइक बाउंड टू ऑफ दिस टुगेदर, ऊपर वाले दोनों अपन को बाइंड करने हैं, तो ये वाला हो जाएगा, है ना। ये लाइंस तो लाइक दे आर लाइक दे विल कंटिन्यू टॉप बॉटम लेफ्ट राइट सब, बट ये बाउंडेड एरिया हो गया, है ना। तो इज दिस फंक्शन कॉम्प्लेक्स इनफ टू शेटर दिस दीज पॉइंट्स दीज रिजल्ट्स। एंड ये सही में मैटर नहीं करता, लाइक इफ यू ट्राई दिस मल्टीपल टाइम्स, ये सही में मैटर नहीं करता कि तुम यू आर मेकिंग अ 3 पॉइंट थिंग ना। तो इट डजंट मैटर कि 3 पॉइंट हम ऐसे बनाएं या फिर हम 3 पॉइंट ऐसे बनाएं या फिर हम 3 पॉइंट जो है ऐसे बना लें। इट रियली डज नॉट मैटर, क्योंकि इन दी एंड जो शेप है ना, दिस शेप जिससे हम बाउंड कर रहे हैं या टॉप और बॉटम को क्लासिफाई कर रहे हैं, दैट विल जस्ट एडजस्ट इटसेल्फ। डजंट मैटर अगर वो 3 पॉइंट है तो 3 पॉइंट के हिसाब से वो एडजस्ट कर लेगा अपने आप को, है ना।
अभी हाँ थोड़ा आया तो है उस डायरेक्शन में, राइट।
And there is one more complex thing that I wanted to explain, weirdly enough. Um, but like, think about it like this: W1, W2, W3 can make 3 lines, right? True. That is how you that these three will show कि हम 3 lines बना सकते हैं. But here's the thing: अगर हमारे पास है ना ये 3 चीजें हैं, to be and we want to classify this, there is a scenario, ये बस मैं बता रहा हूँ and this is like way more complex compared to जो अपन को है actually में syllabus में, but there is a scenario जहाँ पे है ना अगर इतने decisions हमें लेने हैं तो with just W1 and W2 you can make these decisions without any issue. एंड इनफैक्ट जब हम प्रोग्राम करते तो इसका x1 W1 प्लस x2 W2 से हम काम चला लेते हैं 3 रिजल्ट्स में। बट हियर्स द थिंग, जो सिंगल लाइन होती है ना, दैट शैटर्स दिस होल थिंग, लाइक सिंगल लाइन कैन शैटर 3 डिसीजंस। बट द वियर्ड थिंग इज कि जब हम इसका एल्गोरिदम लिखने जाते हैं, अनलेस वी आर लाइक डायरेक्टली डूइंग इफ एल्स, कि इफ अगर ऐसा रिजल्ट आए तो ऐसा आउटपुट, ऐसा इनपुट आए तो ऐसा आउटपुट दे देना, तब तक है ना हम इसको एक्चुअली में ऐसे शैटर नहीं कर पाते। मतलब वी कैन नॉट एक्चुअली सॉल्व दैट प्रॉब्लम विद जस्ट वन सिंगल लाइक वेरिएबल। बट with machine learning it finds a way, पता नहीं कैसे करता है, nobody knows, like there is no book out there that will tell you कि ये कैसे होता है, but there is a way जहाँ पे 3 decisions होते हैं हमारे पास, जहाँ 3 results होते हैं हमारे पास, वहाँ पे single weight can classify between those 3. Somehow it does that, somehow it stores all of that information in just a single weight, and there is like no explanation to this anywhere.
Okay.
So
My questions are done. Like I'm done. For
कुछ नहीं है, इसको ना रिवाइज करोगे ना एक आध दो बार, एंड व्हेन यू डू लाइक मोर न्यूरल नेटवर्क्स यू प्रैक्टिस, दिस विल बिकम सो मच क्लियरर, लाइक पता नहीं कैसे होता है लेकिन वो क्लियर हो जाता है।
किसी को समझाने जाएंगे ना खुद ही समझ में आ जाएगा।
ना ना एक्चुअली में मशीन लर्निंग हो जाती है अपने साथ, पता है, बहुत बार प्रैक्टिस कर लेते ना उसको तो।
हाँ सही में। ठीक है,
चलो ठीक है, आज
अभी कल मिलते हैं फिर हम।
कल मिलते हैं, कल यश की क्लास है।
अच्छा, वो FDS पढ़ाएगा कल 10:30 बजे।
हाँ
ठीक
कल
है,
हम भी पढ़ेंगे थोड़ा सा।
ठीक है। अरे वो प्रोजेक्ट का भी बता देना जब
हाँ मैं प्रोजेक्ट
कनेक्ट
में
करना हो।
yesterday I spent like half an hour on that.
हाँ।
वर्ड लिस्ट मैंने निकाल ली है एंड आई एम ट्राइंग टू एनकोड इट नाउ धीरे धीरे करके। तो
मैं बस क्या सोच रही थी ना, एक ही सिटिंग में बैठ के निकाल दें, अगर कुछ ऐसा हो तो। आई एम तो अवेलेबल इन डे टाइम एज वेल,
हाँ
तो अगर कुछ
तो
ऐसा हो
एक
तो
काम
बता
करते हैं,
देना।
मैं कुछ वर्ड्स है ना, आई सेंड यू सम वर्ड्स, अपन को है ना मैक्सिमम 500 वर्ड्स करने हैं,
हाँ हाँ,
एंड देन विद दोस 500 वर्ड्स विल लाइक एड इट टू एक पुराना जीपीटी मॉडल में, और वो उस हिसाब से आउटपुट दे रहेगा तो बना जाएगा।
तो मेरा क्या है ना, जैसे रिपोर्ट के लिए बैठे थे ना, वैसे जब भी तुम्हारे पास 1-1.5 घंटा 2 घंटा हो तो मुझे बता देना। आई विल कम, लाइक डे टाइम में भी मैं हूँ अवेलेबल।
हाँ
ठीक है,
कल कोशिश करता हूँ मैं, आई एम लाइक थिंकिंग मैं अभी एक आध वीक ऑफिस ही ना जाऊँ, तो इट्स बेटर
तो
20
मेरा
दिन तो हो गए।
सिनेरियो है कि मैं नहीं जा रही हूँ, तो इसीलिए मैं बोल रही थी
हाँ
कि दिन में अगर 2 घंटा 3 घंटा लगा के इसको क्लोज कर सके तो आई विल बी
हाँ
हैप्पी टू डू दैट, जिससे
ओके।